Okay, hello my subscribers. Today edition, just want to give update. In my previous update, my previous video, I use two battery, which is I make it to 24 volt because this motor here can drive on 12 volts and 24 volt maximum. Can drive on 12 volt or 24 volts. Just a change of speed and power. Okay, here is a Tiger generator. Some people refer it as 950 watt generator. I have already dismantled the engine part, the mechanical part. Just only consist with electrical part, which is the stator and the loto. So I only modify the stator. I only modify the stator. I only modify the stator. So in my previous uh, experiment, the system was charging, but the system was charging, but just going down after some 7 to 10 minutes thereabout. Okay, um I have already do some winding, change of winding. So you can see there is a lot of wire, and the other wire is for AC, which is the the capacitor. So because when the motor rotates, it turn the armature, the rotor. So now when the I connect this motor to the 12 volt battery to explain the armature, which the armature will get induced and generate a voltage, and that voltage AC, and that voltage will be uh, transferred to diode, bridge rectifier diode, and the that bridge rectifier will be we convert the AC to DC. We convert the AC to DC, and if you check here, this is a capacitor, and this capacitor is consists with 62 volts. So the maximum it can handle is 62 volts, and you can see it is 10,000 UF, 10,000 UF microfarad. I mean 10,000 UF electrostatic capacitor. This one here is a microfarad. So they work the same, they do the same job, but in different categories. This one store in AC, so this one store in DC only. If you connect to the AC source, it will get you damaged because it can. If you check this line is for is negative, which means even if you trace it from here, it is connected on negative sign here. Then the other side here is for positive. So if you can see, it is a positive terminal. So I just decided to use a uh, solar control charge controller. So you just to monitor the voltage going to the battery, just to monitor the voltage going to battery. If you check the you can see. Okay, let me turn it around. You can see it is rated voltage is 12 to 24 volts. Rated current is 50 amp. So I just decided to use a 12 volt battery, um 7 amp, 12 volt 7 amp. So let me do the connection here. Okay, let me connect the negative terminal. Let me connect the negative terminal. Okay, let me connect the positive terminal to the battery. Okay, So there's a power display. Okay, the voltage of the battery is 12.4 volts, and you can see this sign here. This sign here is a sign of that the controller, mean the solar panel is at night, because you know that solar panel doesn't work at night. So you can see it is a display of moon and star, which means that there's no any input to this terminal, because it is a solar charge controller. So it displays that there's no any power here. So you can see when I start the system, when I connect the terminal of the motor and the motor road the generator, you can see this uh, uh, symbol here will disappear, and when you disappear, it will show a sun sun display, which means that now there is a power input here, because solar work at the day, not at the night. Work in the day, not in the night. Okay. So now let me connect uh, this terminal of the motor, to the battery. Okay. So let me do the connection. uh, so that when I connect the motor terminal, you can see this arrow will disappear. And again, I think there is I make a mistake on the connection. Okay, so now let me do the connection. The reason why it is displaying is I have already started previously, so let me connect it again. Okay. You can see there is a display. So I can see I joined when I joined the two capacitor, the voltage of the increased a bit. So I joined two capacitor from 11.8 to 11.9 PV. So which means that uh, uh, I have to get at least two or four of this capacitor to increase the capacitance or increase the storage. So 1.2, 1.3 amp. Okay. Still on 11.9 volts. The input, the PV means the the input from the on this diode. So that's what the input means. You see, the input PV. Okay. So let me connect. Let me connect. Get this 12 volts. Let me see what it will, whether it will go down more. Let me see whether it can go down more. So it has reduced a bit. So I think from what I can observe from here is that because I use 0.6 mm. I use 0.6 mm in this winding. So it seems to I have to use something as 0.7 or 0.8 mm. Give 2.3 amp. When I tested the voltage, when I didn't connect any load, it was around 13 to 14 volt. So because of the insufficient current, it bring it down to 11.8 to 11.9 volts in the system. So it have already spent around more than 8 minutes. So I think the system need a lot of adjustment, either increasing the tones, reduce the gauge, or maybe increasing the gauge and reduce the tones. Though, but the voltage is around 13 to 14 volts. So I think you need increasing the gauge of wire. So that's what you need, so that the current we can see now, the PV has now go to 11.6 or 11.7 volts. You see, 11.6 or 11.7 volts. Okay, so that's what I have for today. But the current is still at the same 1.2, 1.3 amp. 1.2, 1.3 amp. So I see this amateur here is the one I I use a brush to send power. So this one doesn't use any capacitor because it is permanent. So I send power here to form permanent magnets from electromagnetic. So there's no need of any capacitor. So I think my next video I will use this uh, load so that I will it will be easy for me to increase the voltage of the generator by sending more power, either increasing the voltage, the current that goes to this rotor. So I think I will use this armature in my next experiment, so that it can be easy to increase the voltage and decrease it. So because assuming if I use this armature now, I can put more power, then the voltage will increase. So I'm suggesting that is what I will do in my next experiment concerning the system. Though the system has worked for over 15 minutes now, so just need adjustments. That's what I see about it. Just need adjustment. That's what the system needs. That's what the system needs. Over over 15 minutes now. So which means that where I think the adjustment will come from is the start or change of formation. So that's what I have for today. And when I put VC power, voltage drop a bit, not much, but just a bit.